Hello. I'm going to continue working on factoring quadratic expressions, and this time we're going to make a slight change to what we've been doing. Instead of factoring trinomials of the form x squared plus bx plus c, what we're going to do is we're going to factor trinomials of the form ax squared plus bx plus c, and specifically what I'm going to do is I'm going to show you how do you factor when the quadratic coefficient is not a 1. So what if you have a 2x squared or a negative 5x squared? That's the type of thing that I'm going to be teaching you in this video. So let's go ahead and take a look at an example. All right. Again, factoring ax squared plus bx plus c when a is not equal to 1. And you see here an expression where our a is not equal to 1. We've got a 6x squared for a 6 is our quadratic coefficient. All right. Now, we can't, it turns out, use exactly the same method that we were for factoring when this was a 1 right there. Let me show you how that would work out if we tried it. Alright, for one thing, what we've been doing is we've been saying you find the factors of the constant term that add up to the linear term. And if you want to find factors of 3 that add up to negative 11, well, good luck. They don't exist. Alright, the only thing we could really try is negative 1 and negative 3 because we needed two negative factors since their sum was negative but the product was positive, right? That's not going to work. Another reason it's not going to work is because, well, what we've been doing is we've just been going ahead and saying the first two terms in our binomial factors are each x. Well, x times x is not going to give us a 6x squared, is it? So we've got to find something else that's going to work right here. Our old methods aren't doing what they need to do for us in this case. And so what we're going to do is we're going to make a small modification. Instead of trying to find factors of c that add up to b, what we're going to do is we're going to find factors of a times c, the quadratic coefficient times the constant that add up to b. I'll write that out. So in other words, we're going to multiply the quadratic coefficient with the constant term, and we're going to find factors of that product whose sum is the linear coefficient. All right, using all the technical terms right there. So let's start that off with this expression then. First thing we're wanting to do is multiply 6 times 3, and that's going to give us 18, of course. And then this next part is very similar to what we did in the video. We're trying to find factors of that product that add up to this value right here. Well, the product is positive for the two numbers we're looking for, but the sum is negative. And that means we need to find a pair of negative numbers. Now, you might try negative 6 and negative 3, but they don't add up to negative 11. So how about some other ones? Negative 9 and negative 2. Well, they are going to work, right? This didn't, but that did, because they add up to negative 11. Now what we're going to do with those factors is a little bit different as well. What I'm going to show you is how to factor by grouping, all right? But before we can factor by grouping, we have to create some groups, which doesn't mean a lot to you quite yet, but it will in a moment. What I'm going to do is I'm going to rewrite this trinomial, this 3-term expression, as a 4-term expression, all right, a polynomial of 4 terms. And when I do so, 2 of the 4 terms are going to match the terms that you already see right here. I'm going to go ahead and keep the quadratic term the same, and I'm also going to keep the constant term the same. But what I'm going to do is I'm going to rewrite the middle term, and I'm going to rewrite the middle term as 2 terms using these 2 factors that we found that added up to negative 11. Instead of writing that as negative 11x, what I'm going to do is write it as minus 9x minus 2x. Okay, now you agree that negative 9x minus 2x is equal to negative 11x, don't you? So I've not changed the value of the expression at all. I've just made it look a little bit different. And it's going to be beneficial to me to have made it look different like that. Now how do I proceed from there? Well, here's where the factoring by grouping that I mentioned comes into play. Now that we've got 4 terms, what we're going to do is we're going to group pairs of terms together. We're going to group the first pair of terms together. We're going to group the second pair of terms together. And from each of those groups, what we're going to do is we're going to try to find the common factor, the greatest common factor for the 2 terms in that group. Now, those of you that have seen this method before might have seen where you put parentheses around the 2 pairs of things that you're trying to factor. But I would recommend wholeheartedly against putting in the parentheses because you're likely to make mistakes with signs if you do that. All right, just think, all right, I'm grouping the first 2 terms, and I want to find out what's their greatest common factor. Well, the greatest common factor for 6x squared and negative 9x is positive 3x. So we're going to factor out a 3x. And when you factor out a greatest common factor, you just have to think, what would you multiply that greatest common factor by to get what you started with for each of these terms? Well, 3x times 2x would get me back to 6x squared, right? And then I'm going to put a minus sign. And then what would you have to multiply 3x by to give you 9x? Well, 3. So you should agree with me that 3x times 2x minus 3 gives you 6x squared minus 9x. All right, great. So I factored the greatest common factor out of the first pair of terms. And now what I'm going to do is the same thing with the second pair of terms. Now, what's the greatest common factor for negative 2x plus 3? Well, 1 is really it. But whenever the first term in a group is negative, I want you to factor out a negative version of the greatest common factor. So we're going to factor out a negative 1. Ordinarily, when you factor out a 1 or a negative 1, you don't have to actually have to write the 1. But for what we're doing, it's going to be helpful to do so. All right, so I'm going to factor out a negative 1. And now I have to think about what would I multiply a negative 1 by to give me a negative 2x? Well, that would be a positive 2x. What would I have to multiply a negative 1 by to give me a positive 3? That would be a negative 3. Okay, so there's factoring by grouping. Now, we're not quite done yet, but we've created a pretty cool scenario here. We had 4 terms a moment ago, but when we factor out the greatest common factors from the 2 different pairs of terms, we've ended up with a 2-term expression. It turns out that this product right here, 3x times 2x minus 3, is all one term. And then this product, negative 1 times 2x minus 3, is a second term. And if you look carefully at those 2 terms, they have a greatest common factor of 2x minus 3. If this process is working, these 2 values in the parentheses should always match up with one another the way that those do. You should always have a greatest common factor. And what we can do now is simply factor out that greatest common factor. I'm going to factor 2x minus 3 out from the 2 terms that I've underlined in green. And when I do so, I have to think about, well, when I factor 2x minus 3 out of 3x times 2x minus 3, what remains? Well, the only thing that remains is that 3x. And when I factor 2x minus 3 out of negative 1 times 2x minus 3, the thing that remains is the minus 1. Voila. There's our factored form. 2x minus 3 times 3x minus 1. Now I'm going to show you that this is indeed the correct factorization for our original trinomial by checking the work. And I'll check the work by multiplying the 2 factors that I got to see if they give me the same thing that I originally started with. Now remember, we're going to use the double distributive property in order to multiply these 2 binomials. So I'm first going to distribute 2x to both of these terms. 2x times 3x will give me 6x squared. All right, well, that's a good thing because I had a 6x squared up here. And 2x times negative 1 gives me negative 2x. Then I'll distribute the negative 3 from the first binomial to each of these terms. Negative 3 times 3x is negative 9x. Negative 3 times negative 1, positive 3. And you're going to see when I combine those 2 terms in the middle, I get 6x squared minus 11x plus 3. I indeed, when I multiplied the factored form that I found, got back to the original trinomial. So this is the correct factored form. That's my factored form right there. Great. Let's look at another example or 2. All right, let's try it, and we'll go at a little faster pace this time, since you've kind of seen the process already. We said the first thing that you do when you're trying to factorize a trinomial where a is not equal to 1 is you're going to multiply a times c. So a times c, 8 times negative 5, that's going to give us negative 40. And now what we need to do is we need to find factors of that product that add up to this middle term. Now in this case, we're finding factors of a negative number whose sum is positive. So we want the 2 numbers that we choose to have opposite signs so that they give us this negative product, and we want the larger of those 2 numbers to be positive so that it gives us a positive sum. So think about what some of your factors of negative 40 might be. You might try 20 and negative 2, for instance, but that adds it to positive 18, not positive 6. Well, how about 10 and negative 4? All right, that works out. So then remember what we're going to do next is we're going to rewrite the original 3-term expression as a 4-term expression, where we're keeping the first and last terms the same, the quadratic term and the constant terms the same, but we're rewriting the middle term, the linear term, as the sum of these 2 factors right here with x's added to them. So we're going to have a plus 10x and a minus 4x right there. Right, and this is equivalent to the prior expression because 10x minus 4x is 6x. All right, well, then we start our factoring by grouping process where we recognize we have two pairs of terms, and we're going to group the first pair of terms together, and we're going to group the second pair of terms together, and for each pair, we're going to factor out their greatest common factor. 8x squared and 10x, well, 2x is their greatest common factor, so let's factor that out. And that's going to leave us with 4x plus 5. And you always want to kind of double check mentally to see if you're doing this correctly. 2x times 4x is 8x squared. 2x times 5 is 10x, so we've not changed the value of this expression yet. Then for the second pair of terms, first of all, we're going to factor out a negative because the first term in that pair of terms is negative. And it turns out we're going to factor out a negative 1 like we did last time because 4x and 5 don't have any other common factors. Okay, and so when you factor negative 1 out of negative 4x, it leaves you with positive 4x. When you factor negative 1 out of negative 5, it leaves you with a positive 5. And again, just double check. Negative 1 times 4x is negative 4x. Negative 1 times 5 is negative 5. All right, now, it's a good thing that these two terms, or binomials in parentheses, are equal to one another. Keep in mind now that we have a two-term expression. All right, I've just underlined the pairs of terms, and that those two terms have a greatest common factor, 4x plus 5, and we're going to factor out that greatest common factor, and when we do, we're going to have our factored form. So we'll factor out the 4x plus 5, bring that forward, and then that's going to leave us with a 2x from the first term. It's going to leave us with a negative 1 from the second term, and there we go. We've got our factored form. I showed you how you check these factored forms to make sure they're correct, and you can do the same right now. I'm going to try to do it mentally, though. We're going to 4x times 2x is 8x squared. 5 times negative 1 is negative 5, so the most obvious things are right. And then we're going to multiply our outer terms and inner terms. So if we do 4x times negative 1, that gives us negative 4x. 5 times 2x gives us 10x, and 10x minus 4x is 6x. So yeah, indeed, we've got the right factored form. All right, want to do one more example here. And this time what's going to happen is that the expression that I'm going to factor has a negative coefficient for its quadratic term. But that's not going to change our process whatsoever. We're still going to start by multiplying a times c. Negative 2 times negative 2 times 18 is going to be negative 36. And so now we want to find factors of negative 36 that add up to negative 16. All right. We want the two numbers that we choose to have a negative product, so we want them to have opposite signs. And we want the larger of those signs to be negative because we want a negative sum. So, well, negative 18 and 2, first thing to come to mind for me this time, which is kind of nice because that works. Negative 18 plus 2 is the sum that we're looking for, and it's the product that we're looking for. So let's rewrite this. Then, as a four-term expression, we'll make it negative 2x squared minus 18x plus 2x plus 18. You'll see that that's equivalent to the original expression if you double check. From the first pair of terms, negative 2x squared minus 18x, we can factor out a negative 2x. And when we do so, negative 2x factored out of negative 2x squared is a positive 1x. Negative 2x factored out of negative 18x is a positive 9. All right, now for the second pair of terms, this time 1 is not the greatest common factor, it's 2. And since the first term is positive, we're going to factor out a positive 2. And when you factor a positive 2 out of 2x plus 18, I think you can see how you're left with x plus 9 there as well. And now we've got our two-term expression where x plus 9 is the greatest common factor. We'll factor that out. And it leaves us with negative 2x plus 2. And that would be an acceptable factored form. You might also do one extra thing with this one. You're going to notice that there's a greatest common factor that I could factor out of these two terms. I could factor a negative 2 out, and so I could do that, bring that to the very front. And when I factor negative 2 out of negative 2x plus 2, it leaves me with a positive x and a minus 1. All right, so there's how you factor trinomials when the quadratic coefficient is not a 1. Very simple process once you get the hang of it, and I think that you will get the hang of it. Thanks for watching. See ya.